959.
959.
909.
Well, we're going
It's not the city water, is it?
Pretty good.
Oh gosh, I can't see it.
Given that the sine of theta is equal to 2/3 and the cosine of theta is equal to the square root of 5/3, find the value of the 4 remaining trig functions. So we know the sine of theta, I'm going to write a little bigger, the sine of theta is equal to 2/3. And we know that the cosine of theta is equal to the square root of 5/3. Now, if I draw a right triangle here, I'm going to draw a right triangle for now, and I'm going to call this angle down here theta. I don't care which angle it is. We know the sine of theta is opposite over hypotenuse, or 2/3, right? So it's the opposite side over the hypotenuse, right? So could I go like this? 2/3, opposite side over hypotenuse. I know my cosine. Now, do I really need this cosine? How can I find my third side? A squared plus b squared equals c squared. I could go, let's say this is a. A squared plus b squared, 2 squared is 4 equals 3 squared, which is subtract 4. So we're going to get a squared equals 5. Take the square root, a is equal to the square root of 5. Is that what comes out here when it says adjacent over hypotenuse? Adjacent over hypotenuse is square root of 5, right? Okay. Now I got my sides. Use what we just wrote down there. Find me the other 4 trig functions. Find me the other 4 trig functions. Find me tangent, cotangent, cosecant, and secant. So if I was looking at this triangle here, tangent's opposite over adjacent.
2 over 5.
2 over square root of 5, but we can't have a square root in the denominator, so let's simplify right away. 2 square root of 5 over 5. We multiply top and bottom by the square root of 5 to get rid of the square root, right?
Yes.
Okay, cotangent. Square root of 5 over 2.
How'd you get tangent?
Tangent is opposite over adjacent.
Oh, okay.
So 2 square root of 5, but then I had to rationalize it.
Oh, okay.
Secant is opposite the cosine, which would be
3 square root of 5 over 5.
3 square root of 5 over 5. Okay, that's rationalizing it, right? And cosecant? 3 over 2. Now, we're doing these 6 trig functions. Okay. Now, turn your page. Have a blank sheet paper on the page. I'm not going to give you a quiz, but I want to know how many know it yet.
Hey, you have to put it in.
No.
Well, this is what you just asked us if we know it or not.
No, we're going to see how much you remember. Okay, first question. Cosecant is 1 over what? Cosecant is 1 over what? Question number 2. Tangent is what? Cosecant. First one's cosecant, CSC. Second one is tangent. Third, sine. Fourth, 1 plus tangent squared is what? It was off the proof sheet here. 1 plus tangent squared is what?
You want to like write it all out and prove it? Or just-
What is it? 1 plus tangent squared is what? Last one, 5. Define radian.
Hmm.
Five is the last one? or
Yep, 5 is the last one.
What is a radian?
Yeah, what is the radian? 5 radians. Number 1, cosecant is hypotenuse over opposite. Cosecant is hypotenuse over opposite. Number 2, tangent is opposite over adjacent. Number 3, opposite over hypotenuse. Sine is opposite over hypotenuse. 4, 1 plus tangent squared is
Secant squared.
secant squared. Alex, I know you were right on the proof right away to figure out what it was. That's good. Last one, definition of radian.
Measure of the radius and the arc.
What is radian? Was that?
So it gives the direction. It gives the direction.
Radian.
Measure the length of the radius and measure the arc length.
You're getting closer. The measure of the central angle when the radius and the arc length are the same. The measure of the central angle when the radius and the arc length are the same. That's the central angle.
And the what?
It's the measurement of the central angle when the radius and the arc length are the same. Arc, with RC. Good? Sure. Like it, you can have a sheet in front of you and all this kind of stuff, but they're going to take a little, probably a little harder if you don't have it. A couple more rules on section 2 here. Cofunctions. What about cofunctions? You don't calculate and do it. Cofunction, I always think of 90 degrees. Okay? Or pi over 2 in radians. Pi over 2 is the same as radian. 90 degrees. You know, up here it's kind of small, but up here we have pi over 2. But if I could write each one of these rules instead of pi over 2, if I was using degrees, it'd be 90 degrees. But what works is this. If I take two angles that have 90 degrees, 30 and 60, right? Their cofunction, like you notice here, sine and cosine go together, tangent and cotangent, and secant and cosecant. But what happens here is this. Sine of 30 is the same thing as the cosine of 60. That's how cofunctions work. Secant of 30 is the same as the cosecant of 60. Cofunctions work together. So, and how you find that is you gotta work with the angle. So if I was thinking about this one right here, let's just say sine of 90 minus theta is equal to cosine theta. If I pick the angle like 42 degrees, so the cosine of 42 degrees is the same as sine of 90 minus 42, which is 40 what? 48 degrees. Sine of 48 degrees. Same value. You type them on the calculator, those two values, it'll work out every time. They'll come out to be the same value. That's how cofunctions work. Why we use cofunctions is because sometimes the angle that we're given is too hard to work with, so we rather work with cofunctions. So it's like find the cofunction of the same value of the given expression. So for example, sine of 46. Sine of 46 would be the same as cosine of, what adds up to 90? What 90 minus 46 is what? 44. 44. So my cofunction.
Why are we getting rid of the pi over 2?
This is a different problem. Over here,
No, yeah.
pi over 2 is radians, right?
Yeah.
This is equivalent to 90 degrees. So when my angle is in degrees, I'm going to use 90 degrees. Okay? Now, like this one here, angle is in,
Pi. So we would leave it there.
you leave pi over 2 in there. So it's radians now. If my problem starts off in radians, I leave it in radians. If my problem starts off in degrees, I leave it in degrees. Okay? So like on this one now, what cofunction goes with cotangent? Tangent, right? So this would be, I'm just going to write it out here, it's going to be tangent of pi over 2 minus pi over 12. Correct? Now, how do I subtract fractions? Common denominator. What's the common denominator between 2 and 12? 12, so what do I have to do in this one? Times top and bottom by 6, right? 6 pi minus pi is 5 pi over 12. 5 pi over 12, correct? So therefore we have tangent of 5 pi over 12. The cofunction to this function is 5 pi, tangent of 5 pi over 12. It gives you the same value. This first, go ahead.
What do you use to subtract when they're in radians?
Pi over 2. Pi over 2 in your angle.
Oh, okay.
And when it's in degrees, you use 90 in your angle.
Okay.
A lot of this first chapter is based on just getting to know a lot of the formulas. Getting to know the formulas and how we work them. Calculator. I think we talked about this a little bit. If you use your calculator, find trig function, you calculate, make sure your calculator is in the right mode. I think we talked about this already, right?
That's with the radians.
If you're in radians, you better be in radian mode. If you're in degrees, you better be in degree mode.
How do you switch it?
How do you change it? If you go on your calculator, my calculator up here, and I'll show you a couple things here. There's a couple ways of doing it. I don't know if the newer ones have this. Okay, if under menu, sorry, wrong thing. Go home and go to settings. And there should be number 2 settings here. Mine says general.
Mine never goes in radians. I don't have this.
So Say you can just go to the back. The second one down says angle is degree in radians. So if you're in radians, you should be in radians. If you're in degrees, you're in degrees.
What changes when
You go over to it and click on your right arrow. It changes down and go down. I'm going to go into radians right now.
what does it do? What does it change when you're doing problems?
What does it change? The value you get out when you use sine of 30 degrees.
Oh, okay. So if you're just doing like you're like solving a quadratic equation, will it change anything?
No, it'll just change the trig functions.
Okay.
So I'm going to change mine to radians. I'm going to make it default. I'm going to show you something here. A couple things. You don't have. You can just save it for this document if you want to. If it's your own calculator, you could do this. Reason is this, okay? What is sine of 30 degrees? Okay, let's just do this by hand. What's the difference? Okay, 30 degrees. Let's see how many people remember this today. 30 degrees. On a 60, 90 degree triangle, what's my opposite side? Okay, here's my 60 degree angle, okay? X, okay? Let's assume x is 1. Okay? Think about your special triangle. If x is 1, what's my hypotenuse? 2. And what's my longer length? Square root of it, okay? Everybody agree with me? That's that 30, 60, 90 degree triangle. That was the, but we're always going to use 1. That was the x, the 2x, and the x to the square root of 3. Everybody agree? Okay, now comes the question. If I ask you what the sine of 30 is, what would you get?
It would be 1 over 2.
1 over 2. Sine of 30 agrees is 1 over 2. Correct?
Where'd you get the right triangle on the right?
This one? This one I just said, I just picked side length of 1. I just picked that. That's the one I use when I want to come up with my trig function. I always use side length of 1.
It'll be the same answer for everything?
Yeah. Okay, so I got sine of 30 is 1, right? If I go on my calculator right now and I type in sine 30, I get that. Okay. Why? Because that's sine of 30 radians.
Yeah, I thought I heard my radians and I got one. Yeah.
You might have to save it. You have to save it. Now, if I go like this, I'm in radians mode, right? You could be in radians mode. Now, if we're going to use my book here, and I don't know on Blackboard where exactly I could look for it, there's a little symbol here of degrees. Okay? I can leave it in radian mode and put 30 degrees, and I will get the half. I can be in radian mode and put the degree symbol.
There's a little degree symbol at.
Where's the reason?
On my calculator here, on these, on the black ones, let's see.
It's under your book.
Okay, it's black one, it's under book.
Under book?
Oh.
Yep, under the book, and it's the 4th tab over,
Oh, okay.
degrees. You can be in radian mode and put your degree symbol in, and it knows it's degrees.
Oh, that's so cool.
So, what's the 45?
For sine, you just type in something.
X squared, and then I use,
But you want to be
I'll get it to you in a second.
I have a question. Do you just type in sine every time?
Do I,
Or is
can
there a
you,
button?
what?
Is there a button on these?
Yeah, right there, trig,
And on the chart, that's number 4.
You literally go forward.
trig.
That's it. Yep.
I typed in sine 30 degrees and it gave me sine 30 pi over 180.
You're exactly.
Yes, it does.
Yes.
It wasn't like that though.
My brain is so good.
Don't check the words. Use word. Okay. Now, what is the difference? What is the difference between sine of 30 degrees and sine of 30 radians? Okay. One is radians, one is one. You notice the values are a little different, right? 1/2 and negative 0.998, right? I'll give you a hint. 30 degrees. If I think about axes, okay, 30 degrees is right about, drawing it back to the x-axis, looks like about, right about there, right? That's the triangle we're working with, right? Now, yesterday I talked about a radian being approximately 60 degrees, approximately, right? How many radians in a complete circle? 2 pi, which is 6.28, right? Okay, let's think about that. 6.28. I said 30 radians. That's almost 5 times all the way around. Correct? So therefore, if I did that, 30 radians, what I would do is 30 radians would be 3, 4, up to about right here. That's my angle. That's 30 radians. And then what I would do is draw a triangle and find my sine of that triangle. That's what I would be doing. There's a difference between radians and degrees. That's where I have to get you thinking. You're going to get totally different answers if your calculus are different modes. Now, you know why sine here? Look at where sine is. Sine is 1 over what? Opposite over opposite, right? Look at my opposite side here. On the top one, my opposite side is above the x-axis, right? On the bottom one, my opposite side is below the x-axis. Below the x-axis, what can you tell me about it? Negative. That's why I got negative 0.998.
Where'd you get the 5 times around? How'd you do that?
If I think about 1 time around the circle is 6.28, right? 2 pi. Okay. I told you 30 radians.
Oh, okay.
It's not quite 5 times around, it's a little less than 5 times around. But that's what I'm looking at.
Okay.
Okay? So I want you to understand that when we do these on your calculator, it's a little different. It's not just type in 30 degrees. You could type in. Like I said, if you're in radian mode, I could use the degree symbol, and it knows it's in degrees.
So if you type in sine of 60, you're gonna get 1, right?
Am I going to get sine of 60? I'm going to get 1. Why?
Sine of 60 degrees, you're gonna get 1.
Sine of 60 degrees is not quite 1. Nope.
So how can it be sine of 30 degrees?
And cosine of 60 degrees is 1/2. They're the same value. Cofunctions you're talking about?
Yeah.
Sine of 30. What's the cofunction with sine?
Cosine.
Cosine. What angle adds up to 30 plus what gives you 90?
60.
60. So if I go here now and I type in cosine 60 degrees and I enter, I get the same value. That's what it's saying. That's how that cofunction says. I get the same value.
I think we were saying that since sine of 30 is 1/2, and if you double 30, it'd be 60, so you get 1.
That's what I was trying to
Okay. I know what you're saying.
So therefore, 1 radian will equal 60. Well,
Sine of 30 is done. Sine of 30 is,
I don't know.
I know what you're saying. I know what you're trying to say. It's a good question. You're saying is, if I double my angle, my ratio should double, right? Now remember, what is sine of 30? Sine of 30 is your opposite side over your adjacent side, right?
Yeah.
No, sorry, it's not opposite side over hypotenuse, right? Okay, let's draw that circle. I'm just going to go at the circle works, okay? The radius is 1. That's how a unit circle works. Unit circle is always radius of 1. Okay? Here's my 30-degree angle. Okay? And you said that that's 1/2. Correct? 1 over 2.
Now if you go up to 60,
Whoa.
60-degree angle. Did my hypotenuse change it?
Yeah.
No.
it's the same
Still
distance.
one.
Same distance, so that's still 2. But to this side, you get longer.
Yes.
This side actually becomes square root of 3. And is it double? It changes. The radius is always going to stay the same all the way around.
Yeah.
Just because I double the angle, the ratio is what you're thinking. The ratio doesn't just double.
But then is that bottom one 1?
It's down here? Yeah, that's going to be 1.
So you just
You kind of flip it, yes.
Wait, you could never get the answer 1 because if your opposite side is x, your hypotenuse is 2x.
Yep.
Could never get.
But that's at a 30, 60, 90.
Yeah.
So the hardest was is your quadrantal angles. So okay. So you have to kind of think of it. This radius always stayed the same all the way around. Okay. So that's kind of where you're 2 and 2, but this side is changed as you go. Okay. So we got the calculator, and we kind of angle and elevation and depression, don't you? Let's see. Try this one. A building is 50 feet high.
Oh, I do remember this. Oh, those I didn't know.
Building is 50 feet high. A distance away from the building, observer notices that the angle of elevation to the top of the building to be 41 degrees. Okay, a building is 50 feet away. A distance away from the building, Mr. Crew notices that the angle to the elevation to the top of the building is 41 degrees. How far is the observer from the base of the building?
I don't think it's hard to be first. How do you just observe what someone's
Oh, you're gonna have to.
Wait, is the building on
to
a-
opposite over?
Okay, here's the building, 50 feet.
Oh.
Building is 50 feet high, right? At a distance away from the building, at a distance away from the building, observer notices that the angle of elevation to the top of the building is 41. So from over here, he looks up at the building, notices that it's 41 degrees in elevation.
Oh, yeah. That's the time.
Elevation means from the horizon up.
So why is that the angle?
From the
not
horizon.
The side.
Why is this 50?
No, the 41. How come?
A degree is not a side line.
Yeah.
It's just an angle. And it's from the bottom. When you say the person's looking, I'm looking from the horizon up.
So he just noticed this angle,
Yeah,
but
yep.
he doesn't know.
How far is the observer from the base of the building? Now, what we're looking for is that side.
So
So we look at the side we've given and the side we're looking for. Opposite and adjacent, okay? Let's
So you gotta do tangent.
opposite, adjacent, so we're going to use the function tangent because that's opposite and adjacent. So we're going to say tangent of 41 degrees
50 over X.
is equal to opposite over adjacent.
To put tangent 41 over 1 and you're 50.
Cross multiply. Now, a lot of people like to do a cross multiply and do these problems all the same exact way. They don't all end up being the exact way. You have to make sure you know what you're working with. If I do cross multiply here, 50 times 1 is 50 equals x times this is going to be x tangent of 41. Now I'm going to divide, get x by itself, I'm going to divide by the tangent of 41. So I'm going to get x is equal to whatever that divides out to be.
311.223.
311.223.
So he is standing
311 feet, just to say how it's wrong, 311.223 feet away from the person.
So we don't have to know the other side, like the
The hypotenuse?
yeah. So that doesn't matter.
No. Why is trig developed? I mean, before when we found triangles, we needed to know 2 sides to get the third. With this, we only need to know 1 angle and a side. If it's a right triangle.
When was this first created?
Long time ago. Long
I
time
discovered it.
ago. Okay, next one. Bird sits on top of a lamppost. Okay. A bird sits on top of a lamppost. The angle of depression from the bird to the feet of the observer standing away from the lamppost is 20 degrees.
Hmm.
20 degrees. The distance from the bird to the observer is 25 meters. How tall is the lamppost? I would say it's horizontal.
But is the bird on top of the lamppost?
Yeah, but I would still say horizontal.
So it's not the hypotenuse, is it?
No, no. So what we have, this is a little harder one here. So we have a bird saying we want to know how high the lamppost is. We're assuming the person is 25 meters away, right? And then it's 20 degrees. The angle of depression is 20 degrees.
What's the top?
That's top.
So the top.
Not the top angle, no.
What's the bottom?
And actually what happens here, remember I said from horizon, right? Now if I'm thinking of the person going down, here's my horizon. So his angle, 20 degrees is right there.
So we have to figure out.
Now if you remember geometry,
Oh, I know.
You have to figure out.
all
So then
angle,
It's an inside.
76, it'd be,
what'd you say, Jordan?
Seven.
yeah.
Alternate interior. So if that's 20, down below here it has to be
20.
alternate interior angles.
Wait, why is that?
Here's a parallel line, here's a parallel line, here's a transversal.
Oh.
Alternate interior angles.
Yeah, we did. Osmond.
Yeah. I
So-
know.
Here's a little rule. Angle of depression always equals the angle of elevation. Angle of depression always equals the angle of elevation. So if you know depression, you know you can always put it right down here. Angle of elevation always equals the angle of depression. Now, if I wanted to find this one, really?
Be
Tangent
tangent,
20
tangent.
over, or 70 over 1 equals 25. Right? No?
tangent, 20 is equal to x over 25.
Okay, tangent, if we're looking at this angle, opposite and adjacent, right? So we're going to say tangent of 20 degrees equals opposite side, which is x, over adjacent side, which is 25, cross multiply
25 over 20.
tangent of 20 degrees.
55.
You get
55.9.
55.9. Knowing the sides you have, what are you looking for? Yes. Questions on that so far? Angle of elevation and angle of depression. Oh, wait, no, this is the next section. This is 5.3. As you can tell, once we get to 5.3, we change all the formulas again. So. Okay, little challenge for you. Shh. Give me an easy one to start with.
It's 499.
64. Okay, 496.
Well, we're like,
I saw.
I got two. Hopefully, one.
on page 4.
Wait, did I get one?
40 what?
64.
Well done, What preview? It's a 40. Okay.
I do have the whole book on.
Oh,
If you needed something this weekend,
Do
so that
Like,
the whole sections that we did was awesome.
like, can I get it online?
I get to send you copies. Yep. I can send you
Yeah.
copies.
Yeah.
64, let's go. Now notice how it says in the directions
I'm
here.
not.
Find the exact value of the expression. Do not use a calculator. I better take copies.
What are we, 54, is it not?
64.
Oh.
64, girls.
Oh,
Just for Nancy.
Shut up, Molly.
Okay, let's go. Shh. Did I answer that?
Yeah, maybe.
What?
Can I get the
No,
bottom?
I haven't written it down yet.
Use one cup there. Not use your cup there.
2 degrees greater than 5 degrees.
We don't have to change it over.
I will be, if you don't like working with radians. I know what the angles are, but I don't, if you don't know what they are in degrees, then I would change them to,
So we have to
So
do.
you take
so you
180.
multiply by 180 over 5. If you don't remember what they are.
Wait, how we can charge?
I'll multiply.
Yeah, I'll give you a hint. Pi over 4 is 45 degrees.
What?
Pi over 4 is 45 degrees,
What's
so
pi over 6?
30 degrees. So if I was rewriting this, you might have to help me out rewrite this. What was it? 1 over?
Cotangent pi over 4
Pi over 4.
minus 2 over secant.
Pi over 6.
Dang it, I messed it up.
Cosecant.
It's cosecant.
This one's cosecant?
Yeah,
Yeah.
sorry.
Okay, so I rewrote it. Cotangent of 45 degrees minus 2 over cosecant 30 degrees.
You did it.
Okay?
Good common
No.
What's cosine? Off the top of your head, what is the cotangent of 45 degrees? How many can draw me a 45 degree triangle?
Me.
Half.
45, 90.
45, 45.
45, 45,
Dumb.
90. Correct.
Yeah.
What are my sides? No, that's my angles.
X, X,
X.
Okay, now hang on 1 second. You said an x, and x square root of 2. Okay, now wait a minute. A second ago when we did the 30, 60, 90, I said always make it x what? 1. So if x was 1, what would my sides be?
1,
2. Now if I asked you on here the cotangent of 45 degrees, here's 45 degrees. Cotangent is what over what?
Adjacent over opposite.
Adjacent over opposite, which is
1.
1. So this is really becomes 1 over 1.
Oh, wait, we did that.
Because we did the cotangent of 45. Cotangent of 45 is 1, right? Hey, Carter says let's make a 30, 60, 90 degree triangle.
Ah.
30, 60, 90. And opposite my 30 is x, which is 1. So if this is 1, what's that one?
The hypotenuse would be square root of 2.
That's correct.
X squared.
2 is double.
Square root of 3.
Square root of 3. Oh.
How do you know where to put each one?
Opposite my 30 is always going to be x, which is 1. Okay? My hypotenuse is always twice that. And my other side is the square root of 3.
Okay.
Okay. Now I'm asking go cosecant.
2 over 1.
Cosecant is hypotenuse over
Opposite.
opposite. Hypotenuse is 2, opposite is 1. So this becomes 2 over 2. So this is 1 over 1 is
1.
minus 2 over 2 is
1.
which is
0.
0.
I didn't know 2 or 2 was 1.
Is that the thing that we did in the first chapter?
Pretty sure this is where I gave up in last year.
Okay, let's try another 2 of these.
No.
We got one more. I want to try 65.
No, I feel like an idiot.
You have to practice these. You are not going to go through these like Truman just said. You don't practice these. These are hard. If you practice them, they become easy. We're just talking about this as calculus. Trig functions. And we said they like that. They like to prove
I don't like proving, am I doing?
You need to have girls.
And Stefan Stroga.
Seriously?
Yeah, he's all American Eagle Scout.
Seriously?
Honestly, he's all
He's in Boy
American.
Scouts?
Yeah, he's an all American.
Yeah, I don't know what the girl
Yeah.
Stroll guy though. For the
He goes to six.
Yeah, my dad was at the meeting.
No. Let me
I don't know if they play, so I think you just need to win or the other thing for a second. Yeah, let's go.
Hate stroke.
1 plus sine squared 40. 1 plus sine squared 40 plus.
Sine squared 50.
Sine of 30.
Well, sine is.
Cosecant
Over.
No, sine is opposite over hypotenuse.
What?
Cosine of 50.
Okay. Cameron says co-functions.
Ah!
Co-functions.
Yeah.
Co-functions. She said sine of 40 is the same thing as.
Cosine of 50.
So if it's sine squared 40, it'd be
Cosine squared of 50.
cosine squared 50.
How do you know that?
So I said cosine.
Cosine squared 50 plus sine squared 50.
And that could turn into
That'd be cosine squared 40.
Could, but hang on. We want to give them the same angle. Do we have them the same angle?
Yeah.
Why do we want them?
Okay, now let's think back to yesterday.
But how do you know?
Why do we want
Okay,
this
so
angle?
went from sine of 40 to cosine. How did you know it was 50?
Oh, you could do 42, it doesn't matter. Because since you're both, we wanted to make both angles the same measure.
But no, I'm saying, how did you know it was 50? Did you just change it to 50?
Because 90 minus 40 is.
Oh!
Okay. Now yesterday, one of the rules we talked yesterday, I said the most common rule, most popular rule. Sine squared angle plus cosine squared the same angle is equal to 1. Sine squared
Is equals 1.
Equals 1.
this whole thing right here equals
1.
1. So we got 1 plus 1
Equals 3.
2.
What is the rule is this? Cosine squared of any angle plus sine squared of that same angle is always going to equal
Will that
1.
work for other ones too?
Cosine squared 30 plus sine squared 30 equals
Will
1.
that work?
May I have your attention for an announcement, please?
No.
There will be a
I
short
gave
meeting
the other
at
two you approved
12:30 on the west side of the Commons for boys basketball varsity, B squad, and stats girls. 12:30 on the west end of the Commons.
What's that?
Girls,
Just
boys,
to know
basketball
again about the
meeting.
snowball dance tonight, you have to have all the town guests registered in the office here by noon today. If the students are coming from around town are not registered, they'll be not allowed to come to the dance. That does not include Herman students. Herman students are allowed to come because they are part of the sports team. So anybody else besides Herman kids will have to be registered or they'll be terminated.
We're spending a lot of time. I think we need the time. I'm going to spend the last 4 minutes here today. I'm not going to assign. You do what you need to do in this section. I would assume a lot of it.
I need this time, otherwise I won't be drunk.
Oh, they don't know how to do it.
I'll be like,
3 through 90 by 3s.
What'd you say?
3.
3 to 9 by 3.
Okay.
We have 2
Okay,
lines that all.
here's the deal. I kind of hate. Right now, I like the discussion we're having where stuff is doing, practicing problems in class. I want to keep the weekly quiz, but I don't want to take the time in class to do a weekly quiz because I can imagine if I gave you 2 of these problems, we spend the whole hour Monday doing these 2 problems.
Yeah.
Don't be surprised if you get your weekly quiz on Sunday or Monday outside of class.
What happens if we don't get notification on Sunday?
Just check it because there was a notification last night to give me 2 definitions.
I
I gave us that you can't do that.
I don't get notifications. I don't get notifications.
You think I didn't? I know it was the first thing on my mind.
You're kidding,
So,
right? It should have been.
but-
You should put this
Three
away.
through 90 by
If we don't have school Monday, you're still getting the quiz.
No, I would start off
I thought we
my.
were saying Monday.
True, if you're gonna break the phone, do it.
I'm actually breaking my ear.